The first startup we will hear about is Ashaya from India. So please welcome Anish Malpani. He is co-founder of Ashaya Recycles Private Limited, a startup based in Pune in India. And well, have you ever considered what could be done with chips, plastic packages? So here's one in his hand. So we're not talking about the electronic chips in your computers, but the chips you eat in front of your TV at home. Right? Yeah, so Anish will present a solution to us and also explains why, well, strictly speaking, he should wear sunglasses on stage. So
don't give it away, Alexis. Awesome.
Forwards, backwards.
Awesome.
Okay.
Hi, everyone. Nice to meet you all. My name is Anish Malpani. Did you know that these packets of chips that we love so much are impossible to recycle? It's because they're made from many layers of plastics and materials fused together. So you have different types of plastics, aluminium, sometimes paper, and they're very inconsistent. So a chips packet is different from a chocolate wrapper, different from a Tetra Pak, and as you chemists know, when you mix materials, recycling is impossible. It's for this reason that less than 1% of this is recycled globally. 80% of all ocean leakage from land is not straws or not bottles, it's flexible packaging like packets of chips. It's honestly the worst kind of plastic waste out there, and nobody wants to talk about it. So for the past 2 years, we've been researching in our lab in Pune, India, on how to recycle this in a green way, not for some story, and we found a way. So we take this MLP, and our patent-pending process separates the layers and converts them into high-quality materials. Now, since I'm at a chemistry conference, I can't talk about technology without confusing people. So when you take this MLP and you put it into a reactor, a patent-pending process does 4 things simultaneously. Number 1, it partially delaminates the multi-layered packaging. Number 2, it dissolves the metal, aluminium, completely at 100% dissolution almost. And the third thing, which is really important, is that the PET, the polyethylene terephthalate, which is an aromatic polymer, gets completely dissolved and converted into its monomer PET. And the fourth thing is that it goes through a nice caustic wash, which cleans this really dirty waste, which is full of oil and food particles and all kinds of things, right? So all of these 4 things happen simultaneously, and we get these 2 building blocks. We get a mixture of polyolefins, which is polypropylene plus polyethylene, and we get the monomer of PET. We take the polyolefins and we convert them into high-quality pellets, which can be used in injection molding, compression molding, and we're working on 3D printing filament as well. And we take the PET, the monomer of PET, which is terphthalic acid. We take the monomer of PET and we convert it into virgin PET. We're super excited about this because infinite loop, but it's still a work in progress, and it's something that we're raising funds for. So what's unique about our process is that if you are familiar with the waste management space, the current solutions for flexible packaging or impossible to recycle plastic is you burn it for energy, or you burn it in the absence of air to make fuel, or you mix it with concrete and cement to make bricks and roads. These are all end-of-life solutions where you're delaying the inevitable. There's poor economics. It's low application. It's more of a down cycle and an end of life. So what's different about our technology is because we extract materials, the new material we create is way more recyclable than the original MLP. Conventional recyclers can recycle them in their stream. We don't have to get it back. Okay, we get close to virgin-like mechanical properties. It's toxin-free. We've passed REACH and ROHS compliance tests. And it's consistent. As a manufacturer, you need consistent material, and we get consistent material batch to batch. We got this material, and the first thing we did with it is we made the world's first, world's first recycled sunglasses from packets of chips. So we launched these sunglasses at the beginning of this year in February in India, and it went a little viral. We sold out in the first 6 days. We were covered by close to 100 news publications, and it did really well. And just to let you know what the sunglasses look like, the frames are made from 90% recycled polyolefins. And this is important. It's a true 90%. The 10% we add are additives and compatibilizers. we do not add any virgin plastic. So industry would say 100% recycled, but that's not right. It's a fully functional pair of sunglasses, UV polarized, and it has all of the other properties that, it's virgin-like properties, like I mentioned, higher consistency, toxin-free, it's more recyclable, and it's scalable at competitive prices. And this is really important for us, right? Like, it's not just a story. We want to be competing with virgin plastic prices, right? And with virgin plastic properties and moldability. Yeah, there's a QR code that tells you the story. So when you scan this QR code, you get to see how these sunglasses were recycled. And this is important because sunglasses is just a placeholder, right? A manufacturer can have any product on there. You can have Unilever can have bottles, you can have other, Warby Parker can have other sunglasses, but the story would be the same. And this is something that we're really proud of. So when you scan this code, it takes you to page that says that, these are sunglasses. One sunglass is made from 5 packets of chips, and, you get to see, like, which former waste pickers worked on it, how did their lives improve, where did the waste come from, not in India, but in which scrap shop in Pune, which is run by these 12 to 14 ladies who live really poor lives. And that's really important, because when you look at India, the waste problem is a lot more complex than just an environmental issue. We have close to 4 million waste pickers or rat pickers who live really poor lives, working in the waste without PPE, with their children on their back sometimes, having really low life expectancy. So you have to, any solution that is coming, that we're building, has to include the waste pickers into the equation. So we've built our process in such a way that 50 to 75% of the process can be run by waste pickers. And so you see them working right alongside our scientists and engineers. We formalize them, give them dignified labor, we upskill them, and they are very much part of the process. So we imagine a world where all waste is a resource, and all waste pickers have graduated to better livelihoods, and that we are impact first. Our focus is on how many people we push out of poverty, how much waste we divert. So our focus is on depth in the short run and scaling that depth of impact in the long run. And we're just getting started. So in the end, we are a material science company, right? And we're looking to raise our seed round for $2 million. We've already gotten $1.6 million committed. We've already, off that $1.6 million, we've already closed a $600,000 convertible note that is done. So we're looking for another $400,000 to $500,000 from true impact investors, true patient people who are willing to partner with us as we try and solve this really complex problem from both an environmental and social perspective, with deep technology at the heart of it. I haven't talked about business model. I haven't talked about all these things. So I have all the information. My appendix is 50 pages long, so if anybody wants to ask any questions, happy to kind of talk through all of the important detail afterwards. Sorry, Alexis, and thank you so much. Check out the sunglasses, huh?
Anish,
what's up?
Let me ask the question that everyone has in this room. Where can we buy these sunglasses?
That's a good question. Right now, it's only sold in India.
Okay.
But we're trying to sell internationally. I have some samples with me for you guys, but I don't know for the rest. Huh?
Investors, please make sure that this will enter the global market, of course.
Yes, thank you.
Thank you.